right, we're going to look at hyperbolas here. Graphing hyperbolas. So we're going to look at, there's two general forms of hyperbolas. You have hyperbolas that open left or right. If we make a quick sketch of that, they will look something like this. You'll have one branch of the hyperbola that opens left and one that opens right. Then you have hyperbolas that could open up or down. So you have one that opens up and one that opens down. If your hyperbola opens left and right, the equation will always start with the x squared first. It'll be x squared over a squared minus y squared over b squared equals 1. If the parabola opens up and down, instead of starting with x squared, it will start with y squared over a squared. A squared in this case is the first one in both. So y squared minus x squared over b squared equals 1. All of the hyperbolas that we're going to look at today are going to be centered at 0, 0. So you don't see the hk in this equation because the center is 0 for all of the hyperbolas in these notes today. The C will be our foci, or focus points. And you will use this equation, a squared plus b squared equals c squared, to solve for c as well. So what are the similarities and differences from the ellipse? Well, remember, the ellipse's equations were x squared over a squared plus y squared over b squared equals 1. So they're similar, as in you have the a squared, the b squared, and they're both equal to 1. One main difference is that in the ellipse it is plus, and in the hyperbolas it's minus in both of them. Another key difference is that the a squared was always the bigger value. So if the a squared was under the x squared, then that meant that the x was the major axis. And if it was the other way around, if it was, it could be written like x squared over b squared plus y squared over a squared equals 1. Then this one means that the y was the major axis. However, in the hyperbolas, the a value always comes first, and if it's x first, it tells you it opens left and right, and if it's y first, it opens up and down. So that's some key differences, but also some similarities. They're also both equal to 1. That's important. Another similarity, but also a difference, is that for an ellipse, to find the foci, we did a squared minus b squared equals c squared. For a hyperbola, we do a squared plus b squared equals c squared. So they're similar, but they're different. This one's a plus, and this one's a minus for the ellipse, and a plus for the hyperbola. I remember it because they're like opposites of the equation. The hyperbola equation is a minus, and the ellipse equation, the foci, is a plus. The ellipse equation is a plus, and the foci equation is a minus. So they kind of go opposite of each other there. It's just a helpful way to remember it. All right, so let's look at graphing this. These are some directions in graphing it, and this will be good to reference back as you do some examples. It doesn't make a lot of sense without actually doing examples, so I've included that off to the side of the notes as well. So the first thing is to identify is that this hyperbola starts with an x squared value, and so this will be opening left and right. Now the a squared value is always first, and the b squared value is always second. And then similar with the ellipse, this 9 is under the x squared, so along the x-axis you will be going a value, so a is 3, so along the x you will be going to the right 3 and to the left 3. And that's because our center is at 0, 0 here. And then similar, b is going to be equal to 2, the square root of 4 here. It's under the y, so along the y-axis, you will be going up 2 and down 2. Now, we're going to use those 4 points to help us figure out what our asymptotes are and what our vertices are. So first, our center is at 0, 0 because we do not have no HK in the equation. This equation does open left and right, so these points are going to be our vertices, our A values. So it's going to be vertices, remember those are x, y coordinates and they're on the x-axis, so those points are going to be 3, 0 and negative 3, 0. So I first put those 4 the vertices and the 2 other points on there, and then I drew a dashed box. That box is going to help me draw what's called my asymptotes. These asymptotes are going to be connected from each corner of the box, so that corner to that corner. So it's going to be a dashed line all the way through that diagonal, and then if I go through the other diagonal of that hyperbola, so those are my asymptotes. And if you remember asymptotes from when we graphed other functions, asymptotes are like invisible lines that the function, or this, in this case, the hyperbola, will get very, very close to but never cross. So these asymptotes will serve kind of as a guide to when we're drawing this hyperbola, because the sides of the hyperbola will get really close to those asymptotes, but they'll never cross it. Now we're going to use, this is the point slope form. And we're going to use that to write the equations of these lines, the hyperbolas. Now when the center is in the middle at the origin, 0, 0, that's going to be the point that we're going to use. So that's going to be my x1, my y1, because it makes it very easy to plug into this equation. Then I need to find my slope, and you have to remember that slope is rise over run. So if I look at the first diagonal dashed line, my hyperbola, if I go rise is rise of 2, run of 3. So that's a positive slope of 2/3. Then the other equation has down 2 to the right 3, so the slope is negative 2/3. So I have one positive 2/3 for a slope, and this equation, or this line. So this line, the slope is positive 2/3. This line, the slope is negative 2/3. And they both go through the origin. So when plugging into this equation over here, y minus 0 equals 2/3 x minus 0. So really it's just going to be y equals 2/3 x. And then the other equation is going to be y equals negative 2/3 x. So that's the equations to the 2 asymptotes. Now you'll need to find your foci, which, since this is minus here, that reminds me that it's going to be a squared plus b squared equals c squared. So my a squared was 9 plus b squared is 4 equals c squared. So 9 plus 4 is 13 equals c squared. Take the square root of that, and c is going to be the square root of 13. As ordered pairs, that would be, they're going to be on the x-axis. So I'm running out of room here, but it's going to be, let's see, the square root of 13, 0, and negative square root of 13, 0 will be my foci points. Maybe I can erase some stuff here and fit that over here. So negative square root of 13, 0, and square root of 13, 0. Now the square root of 13, to graph that, you're probably going to want a decimal. So the square root of 13 is approximately equal to 3.6. So that's 3.6 and 3.6. So now I have my vertex or vertices. So the hyperbola is going to go through that. And then the focus, it's going to be focused around this point. And then it's going to go really close to this asymptote but never cross. And then really close to this asymptote but never cross. Same on this side. Really close to this asymptote and never cross through the vertice, really close over here. So then the blue, solid blue lines right here and over here are my hyperbola. All right, let's see if I can fit in one more example here. We'll do this one since it's not equal to 1, similar with the ellipse equations, you have to get it equal to 1 before you can graph it. So that will simplify to x squared over 4 plus y squared over 25 equals 1. Then remember, this is always a squared. Whoops, I put a plus in between there, but it's supposed to be a subtraction sign always. And this one's always b squared. Again, since this one is x squared first, this one opens left and right as well. I'm only allotted 15 minutes for this video, so I have to try to hurry here. The center will be 0, 0 again. So we'll start at 0, 0. Along the x-axis then, I will go over 2 and to the left 2 because a is 4, or a is squared is 4, so a is 2. B squared is 25, so b will be 5, so that's up 5. And then from the center down 5. That's going to give me my graph. Since this one opens left and right, the vertices will be the 2, 0 and negative 2, 0. If this one opened up and down, the y coordinates would be my vertices instead of the x coordinates. That would be the main difference. So for asymptotes, those are going to be these dashed lines from the, oops, let's undo that. It's going to be the dashed line here through that center of the box down to that center, and then through that corner of the box through the center and down to that corner of the box. We're going to use the 0, 0 point again for your x1, y1 since it does go through the origin. That makes it the easiest point to use. So for the slope for these, you're going to go up 1, 2, 3, 4, 5 over 2. So the slope for this one is 5 over 2. The slope for this one will be negative 5 over 2. Or plus and minus 5 over 2. So asymptotes, you're going to have one positive slope and one negative slope, 5 halves x, because x1 and y1 will just be 0. As for your focus, since this equation is minus, I'm going to remind myself that that's going to be a squared plus b squared, then the opposite. A squared is 4 plus b squared is 25 has to equal c squared. So c squared equals 29. So c will equal the square root of 29. I was trying to erase this, so I had a little bit more room here. I can rewrite that up here. These are on the x-axis again, so it's going to be the square root of 29, 0, and negative square roots of 29 and 0. The approximately square root of 29 will be approximately 5.4. So 1, 2, 3, 4, 5.4, and 1, 2, 3, 4, 5.4. So the focus is further away from my vertex, which means that the hyperbola is going to be wider, and look how wide it is. Remember, this is going to be my vertex point, and then I got to follow my asymptotes, and they're going to get really close to that asymptote but never cross. So go through the vertex point, get really close to that asymptote but never cross, and then opening left and right. The only difference is if it started with a y squared instead of an x squared is that it would open up and down instead of left and right, and then these points would be your vertices instead of the x coordinate points.